The area of a square is found by squaring the length of one side. If we have our square with a side length of s, the formula for the area is s squared. If you know the area and want to find the length of any side, then you will need to use an inverse operation or an opposite operation. So here we have the numbers in the right column of this table are squares of the numbers in the left column. So 1 squared is 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, and so on and so forth. Now, if you want to undo squaring a number, you must take what we call the square root of the number. The symbol for the square root is called the radical sign, and it looks like this. So the numbers in the left column are the square roots of the numbers in the right column. So for example, if I look at this row in the table, we know that 9 squared is equal to 81, but now if we go backwards, we also know the square root of 81 is equal to 9. When the square root of a number is a whole number, the number is also called a perfect square. So since all of the numbers in the right-hand column have whole numbers for their square roots, this is a list of the first 15 perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Those are all perfect squares. Now, we can then conclude that the square root of the area is going to equal the length of that side of the square. So here's an example. We're told the area of a square is 100 square units. Since we now know the square root of 100 is equal to 10, the length of any side of that square is 10 units. And this can be verified from our prior knowledge that we know 10 times 10 is equal to 100. So 10 squared is equal to 100. An inverse operation undoes an operation. It returns us to where we started. For example, we know subtraction is the inverse operation to addition. If we add 5 to a number and then subtract 5, we get back to the original number. So let's say you have 2 plus 5 is equal to 7, but then you subtract 5, you get right back to 2. We also know that division is the inverse operation to multiplication. If we multiply a number by 7 and then divide by 7, we get back to the original number. So now let's multiply 2 times 7 equals 14, but then if we divide by 7, we get right back to 2. Inverses have that special property. We will explore an operation that undoes squaring a number. So just to clarify, squaring a number is to multiply that number by itself. So when we say squaring 4, that is multiplying 4 times 4 to get 16. That's why we can do 4 squared is equal to 16. So an inverse of squaring would to start with the square 16 and then return us back to the original number 4. That operation is defined as taking the square root of a number. That's the inverse of squaring a number. The square root is an inverse to squaring. Again, we have our symbol for the square root is the radical sign. So here we have, given that 4 squared is equal to 16, it follows from the inverse that the square root of 16 equals 4. See how we got back to where we started from. We started with 4 and then we ended up with 4. Performing that operation and then the inverse returned us to where we started. In this case, the square root of 16 being 4 tells us that 4 multiplied by itself equals 16. You can go back and forth with that meaning because, again, the square root is an inverse operation to squaring.